Hi, math students. It's Miss Carol again, and we are now on Project 2 of Algebra 1B. And the good news here is that there's only 4 sections. Lesson 6 did not have any project questions, but we do have quite a bit to cover in lessons 7 through 10. So I'm going to go ahead and get started with lesson 7 now. We've got 6 questions, and the background information for this is that Raina has finally worked up the courage to take a dive from the tallest diving platform at the community swimming pool. At 0.25 seconds, she reaches her maximum height of 49 feet. At 2 seconds, she hits the water. A quadratic function can be used to represent her height in feet. F of x in terms of time in seconds, x. Okay, so her height is f of x and the time is x. Use what you know about quadratic functions to write an equation for the function and answer the questions. So let's get started here. Using the given information, identify the vertex of the parabola graphed by the quadratic equation. So what they told us is that at 0.25 seconds, she reached her max height. So when we're dealing with a parabola, the vertex either happens at the max or the min. And so we can tell here that our maximum is happening at an x value of 0.25 and a y value or a height of 49 feet. So that is the vertex of our parabola. All right, pretty easy start. All right, use the given information, identify a point on the parabola graphed by the quadratic function that is not the vertex. Okay, so another thing that we know here is right here, we learn that at 2 seconds, she hits the water. Okay, water is our zero here. Water is our ground zero. So that means that at time 2, she's at a height of 0. All right, so we can go down here and say that at a time 2, she's at a height of 0. Okay. Question 3. Use the vertex form f of x equals a times the quantity x minus h squared, that quantity squared, plus k. So that's our vertex form, to write an equation for the quadratic function that represents Raina's height. Okay, so if you'll recall from the lesson, those h and k values in vertex form are actually your coordinates for the vertex. So our vertex is at h and k. But fortunately for us, we already found that vertex at 0.25 and 49. So we know that h is 0.25 and k is 49. Okay. The other thing that we know is one of our x values and one of our y values. So y, remember, is another way to say function of x, and that is 0 when x, or our time, is 2. So we can plug these values in as well, and it'll leave us in a position to solve for a. So f of x is 0 equals a times the x value that we've identified is 2 minus 0.25. Remember, the quantity is squared, and then we're adding 49. Okay, and so that is, got to make sure we've got it all right. 2 minus 0.25 squared plus 49. Don't miss a negative in there. And make sure you've got your k values in the right place. Okay, so that works for that one. scroll down. Okay, so we're going to use that equation that we just came up with to solve for the value of a. So let's rewrite that equation. 0 equals a times the quantity 2 minus 0.25 squared plus 49. Okay, so the first thing I'm going to do is I'm going to do this little bit of math, and I'm going to move the 49 to the other side. So I get a negative 49 equals a times 1.75 squared. And when I do 1.75 squared, I get 3.0625. So negative 49 equals a times 3.0625. So then if I divide both sides by 3.0625, I get that a equals 1 over x. A equals a negative 16. Okay, and that's all you need to write in here. But so that negative 16 is going to tell us a lot about what this parabola looks like. So negative 16. Okay, question number 5. Now that we know the value of a, let's write the generic equation here in vertex form. And so what they're saying is that instead of writing y and x, or values for y and x, we're just going to do generic y and x, but we still need to plug that a, h, and k in. So I know, I'm going to write those values down here. I know that a equals negative 16, h equals 0.25, and k equals 49. So I'm going to just plug all of those in, and that's my generic vertex form for this parabola. And it's what I would put into a graphing calculator to see what the parabola looks like. We can plug any value of x in, and we'll see what our height is at that value of x. So f of x equals negative 16 times the quantity x minus 0.25 squared plus 49. And that's exactly what we would type in there. Okay. And then the last question here, it says use the equation for the function to identify as many key features of the graph as you can. And so because the 16 is negative, because that a value is negative, one of the things that we know is that the parabola will face downward, okay, because a is less than 0. Okay, we also know that the vertex is at 0.25 and 49. Okay, and then one thing that I just want to show you here, it's the dilation, and this is kind of a bizarro concept to wrap your mind around, but it's where the parabola either expands or gets narrow. And so if the absolute value of a, so I'm going to write this out real quick just so you have it, and I'm sure that you're seeing this within the course, but it's worth repeating. If the absolute value of a is greater than 1, So the absolute value of negative 16 equals 16, which is greater than 1, then the parabola or the quadratic equation in question here is steeper than simply x squared, okay? On the contrary, if the absolute value of a is less than 1, then the graph is going to be flatter than x squared. So if x squared looks something like this, then the steeper version would look something like this, and the flatter version would look something like that, okay? So in this case, we can say that our parabola is narrower than x squared because 16 is greater than 1. And let me just bring something over here real quick into the frame. This is the graph in question. I went ahead and put it into the graphing calculator. You can see the formula that I typed in right there, and that's actually, oops, if I go down and click on graph, this is what it looks like. See, I have a max value at 49 and about 0.25, and it's a very narrow parabola. Okay, so that's what it means by that narrow or flatter version based on what your A value is. And that's partly why that vertex form is a really helpful tool, because A, we can identify the vertex really quickly, and B, we can kind of tell what shape that parabola might be. So that is all I have for lesson 7. Please meet me back here for lesson 8, and thank you for your attention.